In this video, we're going to take a look at a problem that's asking us to find the derivative of an absolute value function. So it's always helpful to take a look at a picture of this, and we have a graph of this, and so we realize that because this is a function that can be defined as a piecewise function, let's take a look at a strategy as to set it up. So we know we're going to have two different legs of this function here. We've got, the leg where the slope is negative over here, and then we have the other leg where the slope is positive to the right of that point where they come together and touch the x-axis. So and we're going to have the function value when x is less than some number, and a function value when it's greater than or equal to some number. And the equal to sign is really not that important, as it's not really defined or necessary. But anyways, let's start off by rewriting this function. So we have 1/2 x minus 3 and the absolute value. So the most important thing to realize is that this function really just gets interesting whenever it changes direction. I didn't mean to do that. So if I get that back. When this function changes direction, which is right here at the x-axis. So how do we solve for that point? I guess that's my point. Well, you set the function inside the absolute value equal to 0 and solve for x, and that'll give us on the x-axis where this changes direction. So of course, if we add 3 to both sides, we get 1/2 x is equal to 3. Multiply by the reciprocal 1/2, and we get that x is equal to 6. So it turns out that what we're really interested in is what happens at x equals 6. So we're going to have one leg where it's less than 6, and the other leg where it's greater than 6. So let's go ahead and talk about how do you set up this piecewise function. Well, I like to think of these in terms of two regions. You have the positive region and the negative region. And the positive region, of course, is going to be when x is greater than 6. So to solve this one, you're basically just multiplying it. You're not making any changes at all to this function. But for the negative one, we're 1/2 x minus 3, and you're just going to distribute a negative sign inside of there, and that'll actually change the function and make that negative slope that we desire. So let's rewrite the positive one because there's no change here. So you have 1/2 x minus 3. And if you distribute that negative sign on the negative one, you get a negative 1/2 x. And distributing the negative sign to the minus 3 becomes plus 3. So rewriting this one, we have negative 1/2 x plus 3. And let's take a look at that. So that's this negative leg right here. And where would it cross the y-axis? Well, at the y-intercept of plus 3. And then if we follow this positive leg down, it's going to cross the y-intercept at negative 3. So anyway, hopefully this gives you a little more insight into graphing and setting up piecewise functions. So the next question is, well, what is the derivative? Well, first thing is, this function is actually continuous at 6, right? Because my two highlighted sections, the green and the yellow, come together at 6, but from last chapter we know that you can't take the derivative at a cusp. So let's define this algebraically. So let's start by doing this. How would you set up the derivative of the piecewise function? Well, it's also going to be a piecewise. And let's just take a look at what is the derivative when x is less than 6. When it's less than 6, what is the derivative of a negative 1/2 x plus 3. Just negative 1/2. And what is the derivative when it's greater than 6? 1/2 x minus 3, the derivative of that is just a positive 1/2. So clearly, these two derivative values are different, negative 1/2 and a positive 1/2. So we're not going to assign an equal to sign on any one of these two derivatives. So this is our answer. And of course, you probably could have figured this out just by looking at the graph and see that it's a linear function, which means it always has the same slope everywhere, and the derivative is just the tangent, the slope of the tangent line anywhere on the curve. So there's no variable involved in our exponent, or excuse me, in our derivative. So anyway, hopefully this gives you a little bit of insight into graphing piecewise functions. And we'll do one more in this section.